LineView Overview. The purpose of this video is to provide a top-level overview of the LineView OEE monitoring system applied to a single line. We start with the line overview, which by default provides the line OEE and its component parts of availability, performance, and quality. These KPIs are configurable to match your business requirements. We display units produced, units rejected, and the lost productivity of around 30%, as both the number of units that could have been produced and the amount of time lost. Moving on to the line itself, an indicator is displayed for each main machine on the line. Observing the packer, the system displays its performance, average speed, and the number of times it has faulted during the selected time period. The colored surround indicates the current live state of that machine, and the color coding is shown in the key here, and includes lack and starvation, build back and blocked, and faulted. Understanding if a faulted machine is affecting the bottleneck machine is critical, and this is indicated with white and automatically determined by our causal loss engine. At any point, you can change the time period being analyzed through the time entry menu. You can choose between static, live update, shift to now, or day to now. You can also choose between any two dates and times to analyze a particular period. In the 4-hour period now selected, around 40% OEE loss can be seen across the line, as well as some individual machine stoppages, but identifying which of them contributed to this loss is key, and this is displayed within the loss analysis section. Loss analysis utilizes the 6-loss methodology to separate and clarify these losses so that the correct countermeasures can be applied. It starts with speed loss, in which the actual recorded speed is displayed for comparison against the rated speed, allowing to verify if the bottleneck machine is running at the target speed, as well as how well the line is balanced and its V-curve design. The next category displays planned activities such as changeovers or planned maintenance, and here can be seen a bottle change recorded as 30 minutes, and can also be determined that 25 minutes of that was within the business target, and approximately 5 minutes was over target. So an operator is expected to leave a comment explaining the deviation. A summary of the KPIs are shown on the right for awareness, and below is a display of the automated causal loss assignment across the line. Within the causal loss Pareto, events are separated between breakdowns in orange and minor stops in red, governed by an event time configuration. The top 3 losses in this particular period were the packer, conveyor between the filler and the labeler, and the filler machine, and the resulting OEE loss impact. The packer, for example, was classified as a breakdown, but further analysis is needed to understand when that occurred over the selected time period, and if the issue was resolved. The final category is rejects, displaying the number of rejects that have happened on that line, during line startup and throughout production. In order to observe the impact of the causal losses across the entire line over the selected time period, we have the status screen. For each machine being monitored, a trend line displays core state and utilizes the same color palette as on the line overview screen, with running being shown as black for user clarity. The top loss can be seen here. It's evident that the packer stopped at this point. In turn, the labeler went into blocked and ultimately the blower, at which point the system shows a white bar, which indicates that the issue on the packer has now impacted the overall line by stopping the bottleneck machine. The offset of downstream starvation indicates the volume of conveyor accumulation between machines. The bottom section displays the speed of the selected machine and enables speed comparison pre- and post-planned activities, as well as operator interference monitoring. Machine speeds from multiple machines can be overlaid to assess restart times and speed balancing, both of which are fundamental components of good line control. There are times when it is key for the operator to support automated data capture by providing additional clarity, and this can be done using the operator comment feature. An operator can use the free type fields for concern and action, or use the predefined list of reason codes that can be configured as a drop-down field in the admin section of the application. A username can also be selected to facilitate follow-up as required. At the bottom left of this screen are a number of tool selections. For example, all of the comments that have been added in the selected period can be displayed and filtered as required. Another tool is the retrospective mode adjustment for reassigning loss to planned events or external factors, like out-of-spec materials, or viewing a record of all the products types produced during the selected time period. A simple but very effective feature is focus mode, which only shows machine stoppages that affected the critical machine, allowing the user to hone in on the key issues contributing to lost output. At this point, further analysis of a particular machine may be required, and this is done by selecting the machine name from the left-hand menu. A machine-specific screen is displayed detailing KPIs such as availability, performance, quality, as well as breakdowns and minor stops for the selected machine. Mean measures such as mean time to repair and mean time between failure are also useful for driving machine performance and assessing its impact on the overall line balance. Individual faults logged directly from the machine controller are also trended, and their relationship to the machine state recorded through the first fault causal feature, thus providing true causal loss drill down to machine fault level. It is evident, for example, that the packer breakdown at this point corresponded to a film positioning fault, as indicated by the white bar here. So the LineView system has automatically joined the relationship between the stoppage on the machine and the particular fault that occurred. Speed and machine-specific parameters such as pressures, temperatures, or flow rates that are being monitored on this machine are displayed at the bottom of this machine screen. This completes the tactical system review. For in-depth analysis and trending of performance data, week on week or over a number of months, the system includes a comprehensive strategic reporting suite.